Welcome back to the Deep Dive. Today, we are exploring a transformation in professional training. That moment your digital tutor stops, being just a recording and starts becoming an adaptive, intelligent collaborator.
Right.
We're diving into the latest from EON Reality, announced November 17, 2025. And what we're seeing is a fundamental shift in how they engineer their training.
It's a whole new system.
It is.
Yeah.
It combines their generative AI world builder, Genie 3, with this next-gen avatar brain they call Sentient, and the procedural engine SEMA 2.
And this is about more than just a small improvement. We're looking at a critical inflection point for experiential AI. If you're involved in corporate training, risk management, technical upskilling, this is the deep dive for you. We're really analyzing this move away from traditional static learning, which took immense resources to build towards something that adapts and instructs in real time, everywhere.
And the chairman of the company, Dan Lidgerskar, he has a great quote on this.
He does. He frames it as moving from just showing information in 3D to having an AI that actively understands the world and assists the user. And not just in a simulation, but, standing right there with the physical equipment.
That assistance piece is the key.
It changes the entire relationship.
Okay, so that makes sense.
Yeah.
But before we get into the how it assists, let's talk about that transition. What exactly makes this new ecosystem so different from the old systems where designers had to manually script everything?
Well, that's where the profound difference lies. The before state of immersive training was basically digital filmmaking. A designer had to pre-create every model, script every interaction, record every voiceover.
So if a procedure changed,
You had to rewrite the whole thing, re-render, republish it. It was incredibly expensive and slow.
it sounds like a massive logistical bottleneck.
Exactly. Now, contrast that with the direction of their new intelligent avatars. This is where the efficiency comes in. Instead of weeks of design work, training worlds can be generated instantly via Genie 3 from a simple text prompt.
Like, create a nuclear reactor control room.
Just like that. And more importantly, the intelligent avatar, powered by that sentient AI, it understands the context of that generated world. It recognizes the tools, the equipment, the systems, without a programmer needing to label anything manually.
Okay, so the updates must be easier too.
That's the crucial market shift. If your maintenance manual changes in the real world, the training updates happen automatically just by changing the text instructions the AI uses. The cost and time to create and update expert training, it drops to almost zero.
Right. That's the real aha moment. It sort of democratizes the creation of this high-fidelity training. If you can modify it instantly, the speed at which you can upskill a workforce, that changes the whole equation.
It does.
So once the environment is there, how does this system actually guide the user? The source material talks about a pretty structured pathway. Learn, then train, then perform. Let's walk through that.
It's a very smart structure. It really recognizes how people acquire skills in stages.
So stage one is learn. This is all foundational. It's focused on cognitive comprehension. What is this thing? How does it work? Why does it matter? And here the modality could be VR or even just a 3D desktop model.
Right, the basics first.
Exactly. The system uses the avatar to explain concepts, show cutaways of machines, and even generate these detailed knowledge walls on the fly, just synthesized from the source text.
And once you get the concept, you move into stage 2, train. This is where you build procedural accuracy. It's critical for safety compliance. SEMA 2 takes the text of the standard operating procedures, the SOPs, and it converts them into these precise, measurable, step-by-step tasks inside VR.
So the avatar is like a mentor at this point.
A very active one. It guides you, but crucially, it corrects you and adapts its feedback in real time. If you reach for the wrong tool, it warns you. If you skip a critical safety step, it halts the procedure.
So you're building muscle memory where failure has zero real-world consequence.
That's it. And then you get to stage 3, which source material calls the true game changer, perform.
This is the leap into the real world. You're using augmented reality, often just on a smartphone. The user isn't in a simulation anymore. They're standing in front of the actual equipment. The moment you point your phone at, say, a physical valve bank, the AI vision recognizes the components. It overlays the instructions right onto the real object and guides you. It's like having an expert's knowledge projected onto your task.
And what's so fascinating here is the accessibility. This provides, well, the intelligence of a robot with the dexterity of a human, and all it needs is a smartphone. You're bypassing the need for specialized training facilities or expensive headsets for field work.
It democratizes expert guidance.
It does. Think about replacing a complex part or following an unfamiliar medical protocol in an ER. The avatar is right there, guiding the physical steps.
Okay, so that claim, guiding physical steps, that leads to the real test. The source material details a pump replacement procedure. Let's see how this framework holds up with a real-world high-stakes task.
Absolutely. The pump use case shows the whole continuum.
So where does it start?
It starts in learn. The avatar identifies the components, the housing, the impeller, the seals. It uses a dynamic 3D model, maybe showing the flow dynamics, all inside that auto-generated VR world.
Then you move to train. This is where procedural mastery starts. The avatar makes sure the user follows safety-critical steps like lockout, tagout,
The absolute most critical procedure.
and draining the line. The system detects if you do things in the wrong order.
And it even throws in branching scenarios.
Right.
What if the coupling is stuck? Or what if you accidentally grab the wrong seal kit? This is where excellence is forged.
Okay, but then comes perform. The user is in the real facility.
Right. And the avatar, looking through the phone's camera, recognizes and labels the real valves, the real bolts. It guides the hands-on steps, which tool to use, where to apply torque.
Now, this is where I have to inject some skepticism. The source material makes this incredible claim about eliminating human error. That's a massive claim.
Yeah.
Does the system truly eliminate error, or does it just catch sequencing mistakes? What are the limits here?
That is a necessary distinction to make. And it's a good one. The system is highly effective at eliminating procedural error, missing a step, using the wrong bolt, failing a safety check. The AR overlay gives you certainty that you're following the SOP perfectly, but the system is still constrained by human dexterity. It knows what you should be doing, but it can't physically fix a slip of the wrench or, make sure a person has the strength to unstick a coupling.
I see.
It measures your compliance with the steps, not the finesse of the execution. But even with that limit, by removing sequencing and identification errors, which are the leading cause of accidents, the risk profile drops dramatically.
That makes much more sense. It eliminates the knowledge gap and the procedural gap, leaving just the physical one.
Exactly. It couples digital intelligence with human dexterity.
And while industrial repair is compelling, the breadth of application they list really highlights the scope of this. It's not just about pumps.
Not at all. This applies to the highest risk scenarios everywhere. In energy, they talk about things like nuclear scram training. In healthcare, imagine an avatar guiding a nurse through ER triage or a complex operating room setup checklist.
Or aviation?
Even defense and aviation, yeah. Using AR for critical pre-flight inspections or coordinating a disaster response.
Essentially, this technology is redefining what expertise is. It no longer has to live just in the brain of a senior technician or in some dense manual. It can be instantly downloaded, adapted, and projected onto the physical world.
That is the future vision. Avatars become ubiquitous mentors. The AI understands the physical world around you, making knowledge spatial. And because it's all automated, training adapts at the speed of the industry. It creates this seamless continuum.
So what does this all mean for you, the learner? The difference between relying on memorization versus having an AI collaborator guiding you through a high-risk physical task. It's profound. High-stakes competence becomes instantly deployable.
And if we connect this to the bigger picture, since the system allows for instant world generation and content updates automatically, the speed and cost of creating expert procedural training basically drops to zero.
Right.
This raises an important question for you, the listener. If the economic barriers to creating this kind of expert-level training are removed, how quickly will entire workforces be retrained or upskilled globally? Will this ability to update knowledge so rapidly create a competitive advantage so large that companies relying on traditional trainings simply can't keep up?